Hi and welcome to Simultaneous Equations video 5. In this video I'm going to conclude the last 4 lessons, give a little summary, and we'll look at a couple more examples to help us understand and finalize the topic. Let's say that we had the example y minus x equals 11 and 2y plus x was equal to 1. Again, as usual, I would call this equation number 1 and this one equation number 2. Now, just giving them colours so I can sketch them first. Let's say I'm dealing with equation number 1, y minus x equals 11. I would rearrange that to give y equals x plus 11. And equation number 2, which I'll do in orange, is 2y plus x equals 1. Which means that 2y is equal to negative x plus 1. Notice I'm maintaining that mx plus c notation. And y is equal to negative 1/2 x plus 1/2. So now I'm going to sketch my functions, but first I'm going to choose a suitable axis. And I'm going to go up in 4s. 4, 8, 12. That will give me my access to plus 11 as a y-intercept without overdoing it. But notice also I have gaps of 4, and that makes it easier for me to choose 4 as a good scale to go up in. And I'm going to go up on the x-axis by 2s. 2, 4, 6, negative 2, negative 4, negative 6. So first of all, in pink, I'm going to start with my y-intercept of 11, and I have a gradient of 1. That means I go along 1 up, and I go up 1. Along 1 and up 1. And you can see what's happening. So I go along 2 and up 2 there. And backwards 1, down 1, backwards 1, down 1, so on and so forth. And I can connect these dots, and that will give me my function. So if I draw a line between these dots, there's my function, y minus x equals 11. Now in orange, I'm going to do a second function, but this will be my orange function here with a y-intercept of 1/2 and a gradient of negative 1/2. And that means if I go along 1, I go down 1/2. Along 1, down 1/2. Which also means if I go along 2, I go down 1. So if I go backwards 1, I go up 1/2, I back, and then I keep on going up 1/2 as I go. And I don't have to mark all the points, but you'll get the idea. And there we go. So now I'm going to connect those points to give me this solution. And my graphical solution, which again I'll denote with a red circle, is just here. And that graphical solution occurs at the points negative 7, 4. So the solution is x equals negative 7, y equals 4. Now let's look at this example again using the substitution method and then the elimination method. So using the substitution method, let's copy it down first. Y minus x equals 11. 2y plus x equals 1. So I'm going to call this equation number 1 and equation number 2. And I'm going to use substitution. And to do that, I'm actually going to deal with, in equation number 1, I get this, y equals x plus 11. And we did that rearrangement earlier. And then I'm going to put this into equation number 2. And so that will give me 2y plus x equals 1. Which I'm going to turn into 2x plus 11 plus x equals 1. And I'm going to expand to solve this. 2x plus 22 plus x equals 1. So 3x plus 22 equals 1. Subtract 22 from both sides. 3x equals negative 21. Divide by 3. And x is equal to negative 7. And there's my x solution. And then I'm going to substitute this x solution, x equals negative 7, into equation number 1, rearrange equation number 2, and that will give me y is equal to negative 7 plus 11, which is equal to 4. And there's my solution. X equals negative 7, y equals 4. And of course I should verify here, but I might leave that out for this question as we're verifying by using different methods. So in the elimination method, we start with the problem again, y minus x equals 11, and 2y plus x equals 1. And I can see straight away that if I add equation 1 and 2, so do 1 plus 2, this will eliminate my x's. Negative x plus x is 0x. So by adding them, I'll get this. 3y is equal to 12. Divide by 3, and y is equal to 4. And there's my solution. Now I substitute y equals 4 into one of my original equations. So sub y equals 4 into number 1, and I get 4 minus x equals 11, which means that negative x is equal to 7. I subtracted 4 from both sides, and now I divide by negative 1, and I get x is equal to negative 7. So therefore, y equals 4 and x equals negative 7. But the big question really is, when do we use these different methods? Now, ideally, you want to be using substitution elimination more so than graphical methods. That's a really important feature. This question, clearly elimination was the easiest, and you can see that by the amount of working I've had to do. Now, substitution didn't look too bad because we did have some unitary y and x values, 1y and 1x. But elimination works so quickly without having to do much rearranging. So you can see here, the case is that elimination is probably the best. In other questions, the more you practice, the more you'll get better at picking when to use which one. So I'm just going to show you a second example now. And I'm just going to do this using just one method. So this second example looks like this. X over 3 plus 2y minus 1 over 5 is equal to 4. And that will be equation 1. The second equation will be 2x plus 7 minus y plus x over 4 is equal to 29. And that will be equation number 2. Now we have some issues with this equation and solving it using either substitution or elimination. So the first issue is fractions. We're dealing with some fractions. And realistically, I want to remove those fractions as early as possible. Second issue is a set of brackets. And again, if and where I can remove brackets, I'll be doing that as early as possible. The third issue is equation 2 has x twice. So I need to simplify and combine the x's together. And then lastly, there is no obvious approach here, which makes it really hard. There's no obvious way of adding 2 to eliminate a variable or getting something by itself. Ideally, I can see that x over 3 is going to be a nice one to get by itself and therefore do some substitution. So I might work towards that. But the first thing I'm going to need to do is do some simplification. X over 3 plus 2y minus 1 over 5 equals 4. I'm going to start by multiplying by 3, which will eliminate the 3 from the first term, giving me x plus 3 times 2y minus 1 over 5 equals 12, 4 times 3. And then I'm going to multiply by 5, and that will eliminate the 5 in the bottom of the second term, giving me 5x plus 3 times 2y minus 1 equals 60. Then I'll expand and simplify. 5x plus 6y minus 3 equals 60, and 5x plus 6y equals 63. I'll call this equation number 3. And in equation number 2, I have 2x plus 7 minus y plus x over 4 equals 29. And I'm going to simplify this. First, I'll multiply by 4, and that will give me 8x plus 7 for the first term, minus y plus x equals 116. So that 4 is cancelled out. And notice here you'll see that I added some brackets there. And that's because this minus is being applied to the y and the x. So I need to make sure that the minus continues to be applied to the y and the x. So this will give me 8x plus 56 minus y minus x equals 116, which leaves me with 7x minus y plus 56 equals 116. So now I subtract 56 from both sides. This leaves me with 7x minus y equals 60. and I'll call this equation number 4. So I've now got my two new equations, 5x plus 6y equals 63, and 7x minus y equals 60. Now I have some choices here about my approach, and I could choose substitution and elimination, or I could do it graphically, but I probably wouldn't do that at this stage. So I'm going to choose elimination method. And to do this, I'm going to multiply this second equation, equation number 4, by 6. This will help me to eliminate the y value. So I get my equation number 3, which is 5x plus 6y equals 63, and then equation number 4 times 6. And that will be 42x minus 6y is equal to 360. And then I add them together. So 3 and 4 times number 6 will give me 47x, and my y's are eliminated, 6y minus 6y, and 423. And now I just simply do a division, divide by 47, and x comes out as 9. And now that I know my x value is 9, I'm going to substitute x equals 9 into equation number 4, and that gives me 7 times 9 minus y is equal to 60. So 63 minus y equals 60. Therefore, negative y is equal to negative 3. Subtracted 63 from both sides. And I divide by negative 1, and I get y is equal to 3. So x equals 9 and y equals 3. And that's another example of quite a complex question and how we can solve this quite simply algebraically if we're just careful with our rules and our approach. And you'll see here as I zoom out that it's taken a fair bit of work. So you really need to make sure that your approach is clear, well defined, and that you've not made any mistakes as you go. And all those points that I've put in there are really important. I'd suggest now you take some time in this video, particularly if you're really aiming to achieve those top questions and get them right consistently. Take some time in this video to go through and look at some of those things I've pointed out and maybe make some notes as you approach some other harder questions and see if they relate. Because this example really covers most aspects of simultaneous equations. And the only thing that's maybe missing is working with a question that doesn't give you nice whole numbered answers. And that's the end of our last video on simultaneous equations. All the best.